Everyone, and welcome back to our channel. In this video we'll be talking about negative bases, and you find this topic under exponents on our YouTube channel. So we have an exponent playlist. So let's begin. So what do we mean by negative base? Remember, if you recall, we introduced a to the power of n being the exponent and a being the base, right? The base. So now what happens if we have a negative base? So we want to explore that right now. So let's begin by a few examples. So our first example is going to be negative 1 to the power of positive 3, and that's a odd number. So this is a odd number. So that's a odd number. So what does it mean to raise negative 1 to the power of 3? It means negative 1 times negative 1 times negative 1. And if we simplify, we say a negative. So let's use a different color for that again. So a negative times a negative is positive. So this answer here will yield to a positive 1. Then times this part, so times negative 1 will give us, the answer would then be 1 times negative 1, which is negative 1. So what are we trying to say? That negative 1 to the power of 3 is equals to negative 1. And remember, that's a odd number. So let's write it down there because we need to make a conclusion at the end of this video. So negative 1 to the power of 3, right? Now let's have a look at our second example, and I'm making use of color so that we can see the difference. And now we are working with b, right? So b is negative 1 to the power of 4. What does it mean? It means negative 1 times negative 1 times negative 1, negative 1 times negative 1. So negative 1 4 times. And if we look at this part alone, we know that a negative times a negative. So what I mean is a negative times a negative is a positive. Then a negative times a negative is another positive. So our answer in this case would be positive 1, because we are timesing positive, negative times negative, which cancels out to be positive, and then another negative and a negative. So what do we get? We get that our answer is, so negative 1 to the power of 3 is negative. Negative 1 to the power of 4 is positive. Now let's have a look at another example, and let's not use 1 as our example. So in this case, we're going to use negative 2 to the power of 3. So that's going to be negative 2 times negative 2 times negative 2. And we break it down. We first calculate this part of negative 2. So negative 2 times negative 2 is what? Is positive 4, because the negative and the negative cancel, times negative 2. And that's going to be 4 times negative 2 is negative 8. So that is negative 8. And so that's our answer. So let me just write down our conclusion, or what we have figured out so far. So we have calculated negative 1 to the power of 3. We also have calculated negative 1 to the power of 4. We also have calculated negative 2 to the power of 3. And we got that whenever you power your negative base, so that's a negative base right there, with a odd number, which is 3 and 3 in this case, and odd numbers can be 1, 3, 5, 7, and so forth. So we see that our answer stays negative. But when you power your negative base to the power of a positive even number, or an even number, you get a positive base. So that positive base stays positive. So what are we saying? We have concluded that, or we have proven that negative 1 to the power of an even number, so even number, is equals to positive 1, meaning negative a, which is the number, so a negative base to the power of an even number, is equals to positive of that base to the power of that even number. And that's a rule we need to keep in mind. Now let's move on to the second observation we found out, or we concluded. So we concluded that negative 1 to the power of an odd integer is equals to negative 1. So it stays negative. And then, so we're basically saying negative a to the power of an odd number is equals to negative a to the power of that odd number. That's a rule. That's our second rule in this video. Now, because we have introduced some laws in the previous video, we are going to tackle some questions in this video, keeping in mind that the negative base theories that we have proven. So keeping in mind that a negative to the power of an even number is positive and the negative base to the power of an odd number is negative. So it's a negative. So let's have a look at our first example. And for our first example, we have different bases. So we have 2 to the power of 2 times 3 to the power of 3 times 2 to the power of 4 times 3 to the power of 8. So what do? You first take your color and you underline the terms with the common bases, because we're trying to use this rule. A to the power of m times a to the power of n is equals to a m, right, plus n. We're trying to use that rule. So why should we use that rule, and when should we use that rule? When we have the same basis. So you underline the same basis quickly with the same color. In this case, our 2's are the same, and then we have 3's that are the same. So now you write it down with the colors that you have highlighted it with. So 2 to the power of 2, right, plus 4, because the 2's, we have 2 to the power of something, which is 2 equal bases, right? So we can add the exponents. Times, because there's still a times, so we just put our times there. And we have 3 to the power of 3 plus 8. And so that's how you would write this. And your answer then would be 2 to the power of 6 times 3 to the power of 8. 8 plus 3 is 12, is 11. Yep, 8 plus 3 is 11. So that would be your answer. You can't simplify it further unless you're going to get the individual value. For 2 to the power of 6, you get that, and 3 to the power of 11, you get that. And so let's move on to the next example. So that was A. Our B would also be somewhat the same because we are working with different bases. So we have 3 to the power of 4 times 3 times 5 to the power of 8 times 2 to the power of 3 times 5 to the power of 2 times 3 to the power of 3. So 3 cubed. So what do we do first? We take a different color and we underline the same basis. So 3, 3, and we see the 3 at the end. So we write it down. 3 to the power of 4 plus our other 3, which is this one, has the power of 1, so plus 1, plus our last term there has the power of 3, so we write it like that. And we get that 3 to the power of 4 plus 1 is 5, 5 plus 3 is 8. So 3 to the power of 8, right? So we've gotten the 3. And then now we take another color and we look for other common bases. So we have 5 and 5. So we can write 5 to, so times, there's a dot there, 5 to the power of 8 plus 2, and we get that our answer is 5 to the power of 8 plus 2 is 5 to the power of 10, right? So 5 to the power of 10. Now let's just wrap that so that we have enough space to work with. So I'm just going to underline it. So we say that is 5 and 5. And the last one that we are left is with is the 2, and the 2 is alone, so 2 to the power of 3. So what are we saying? Our answer for this would be, let's write it down neatly. So 3 to the power of 8 times 5 to the power of 10 times 2 to the power of 3. And if you didn't get it, please just go back to the video, to the previous slide, and figure out why we got 3 to the power of 8, 10, and 2 to the power of 3. So let's move on to the next question. And let's keep in mind that this is a mixture of laws that we learned in the previous video. So now our question is, what is 5 to the power of negative 2? So we need to solve that. And looking at this, I can see that we can't, what is 5 to the, we know 5 squared, but we don't know 5 to the power of negative 2. So we need to change that negative 2 to a positive exponent. So how do we do that? We put the whole 5 to the power of 2, then it becomes positive because we put the whole 5 squared under 1. So it's 1 over 5 squared. And if you simplify that, 1 over 5 squared is 25. And that's just it. So that's the answer for that question. Let's have a look at another question. So in this case, we are going to look at 6m squared times 2m squared. And 6m squared, we can see that these are like terms, and we have the same, we don't have the same basis, but we can make the same basis. So how do we do that? We take the whole numbers on one side, so 6 times 2, right? 6 times 2 on one side, and then m squared times m squared on the other side. So let's move on to the next slide because we don't have enough space. So 6 times 2 is what? Is 12, and m squared times m squared. So let's move on. So we said 6 times 2 is 12, and we still had the m squared times m squared. And if we look at this, m squared, same base, right? So it's going to be m to the power of 2 plus 2. So let's just write that neatly, 2 plus 2. And we get that our answer is 12 times m to the power of 4. So that's our answer in this case. Let's have a look at the next question. So the next question in this case would be 2 to the power of 3 times 3 to the power of 12 over 2 to the power of 8 times 3 to the power of 8. So quickly copy this down because we're going to move to the next slide. Or let me just work next to it before we move to the next slide. So we start off by looking at our 2's. It's the same base, so we can use the following rule: a to the power of m over a to the power of n. So you can say a to the power of m minus n, right? So how do we use it? Using the 2's. So we're going to take the bigger 2, and the bigger 2 is on the denominator. So we're going to say 2 to the power of 8 minus the smaller one, which is 3. And then here stays 1 for our 2, right? And then we're going to have a look at our 3's. So let's use a different color for that so that we see the difference. So 3 and 3. So we look at the bigger exponent. Here we have our bigger exponent is 12. And if it's 12, then it's going to be, so our exponent for 3 is going to be on top. So it's going to be 3 to the power of 12 minus 8. And 12 minus 8 is 4. So our answer will be 3 to the power of 4 over 8 to the power of 2 to the power of 5. 2 to the power of 5, because 8 minus 3 is 5. So our answer will be 1 times 3 to the power of 4 over 2 to the power of 5. And if you simplify, 1 times anything is that number. So 4 to the power of 4, 3 to the power of 4 over 2 to the power of 5. And that's our answer in this case. Let's have a look at the next question. So we're going to have different bases again. So 5 to the power of 7 times 3 to the power of 3 times 6 to the power of 3 to the power of 6. 3 to the power of 6 times 5 to the power of 8, all over 3 to the power of 7 times 5 to the power of 20 times 3. So let's use a different color. We are not going to move to the next page. We are going to try and solve this answer right here. So we are going to identify our like terms. So we have 5 and 5. Not our like terms, because they are all like terms. They are all integers. But we are going to identify the powers that have the same base. So yes, in this case, we're going to start with 5 and we're going to check which one is the biggest. So the biggest is 20, right? So we're going to have to take this 7 downwards to 20 and subtract 7 from 20. So minus 7. And we're going to have to cancel where it came from, right? Then let's have a different color to illustrate another. So we're going to underline that. Let's choose a brighter color. Yeah. Now we're going to look at 3's. And we're first going to add 3. So we're going to add 3 plus 6. And you cancel that 3. And then that's going to be 3 plus 6 is 9. And then we're going to look at... So you know what? Let's start all over with this question. And first simplify the numerator, then simplify the denominator. So we are going to start off by simplifying this top part and then simplify the second part and then get to the answer and simplify further. So let's begin. So we're going to start off by, so let's clear everything and then we're going to look at the top part, which is 5 to the power of 7 times 3 to the power of 3 times 3 to the power of 6 times 3 to the power 5 to the power of 8. So that's 5 to the power of 8. And if we simplify that using different colors, this and this match, this and this match. So 5 to the power of 7 plus 8, right, times 3 to the power of 3 plus 6. And if you simplify that, you get our answer to be 5 to the power of 7 plus 8 is 15. So we get 5 to the power of 15 times 3 to the power of 9. So 5 to the power of 15 times 3 to the power of 9. All over. Now let's have a look at our denominator, which was 3 to the power of 7 times 5 to the power of 20 times 3. And we said if a whole number does not have a power, then the power is 1. So we identify our terms that have the same base. So in this case, that's 3. So 3 to the power of 7 plus 1 is equals to 3 to the power of 8. And the 5 stays the same because it's only 5 to the power of 20. So it's going to be 3 to the power of 8 times 5 to the power of 20. And if we were to write that down again, but now simplified, it's going to be 5 to the power of 15 times 3 to the power of 9 all over 3 to the power of 8 times 5 to the power of 20. And we can see that this and this match. So which one goes down? The 15 has to go where the 20 is because the 15 is smaller than 20. So it's going to be 5, 20 minus 15, right, down there. And we have a 9 and a 8. So this 3 to the power of 8 has to go upwards. There's going to be 3 to the power of 9 minus 8. And our answer is going to be here 3 to the power of 1, or just 3 over 5 to the power of 5, because 20 minus 15 is 5. So our answer is going to be 3 to the power of 1, which is the same as just 3, and over 5 to the power of 5. So that's going to be our answer. Now let's have a look at our second last question. We have x squared times x to the power of 3 is equals to what? And that's the easy rule, which is a to the power of m times m. So we add the two exponents because they have the same base. So x to the power of 5. Let's have a look at the last question, which is x to the power of 4. So remember, your exponent or your base can be an unknown, and that's very normal. You just still need to know how to get your answer. So x to the power of 4 y squared over x y cubed. Now let's circle our like terms. So this one and this one and this one. So in this case, x is to the power of 1, right? Because it does not have a power or an exponent, to be clear. So where does this x go? It goes up because it's the smaller one, right? So the answer is going to be x to the power of 3 on top, because we said 4 minus that 1, right? And then this y squared is going to move down because it's smaller, so it's going to be y. 3 minus 2 is 1. So our answer is going to be x cubed, or x to the power of 3 over y. And that's going to be our answer. So thank you guys for watching. See you in our next video as we tackle some more questions and get into the nitty-gritty examples of exponents that you could encounter in your exams or tests. See you in our next video. Bye.